when you try to feed your cat, how do you think you might be feeding it? Dividing it into days or dividing up the pounds?
Days.
So would we want to know in one day how much food I should give them?
Yes.
That's what I don't want to know in how many per 1 pound. I don't want to know, oh, I have to spread 1 pound over 10 days, right? So unit rates, think about what makes sense. If you're going to feed your cat, don't you want to know how much each day you should put in their dish? So we are talking about this unit rate being, this is why I wanted to look at number 1, is we are looking at 3 pounds, was it, or 3 or 5? 3 pounds divided by 30 days. That way, I get a decimal, or I can leave it as a fraction. 0.1, 1/10 of a pound per day. Okay? Change yours if you got it wrong, if you had it different.
Wait,
3
can't you do?
divided by 30. You do not want to flip those two around. Okay? We want to know how much food am I putting in my dog's dish. If you don't have yours, take yours out. Okay? Okay, or in your cat's dish, not this case a dog. Okay, let's go to Crystal. Wait. So now we're looking at Crystal, and she has a 5-pound bag of food, and she knows she can spread it out over 45 days. And it says, at that rate, does her cat, at what rate does her cat eat the food? So we are looking at the food, which is in this case 5 pounds per, and this was in our rate of 45 days. Now, on Monday's quiz, I am going to give you in a sentence kind of like this. I'm going to give you a rate. And one of the first things you have to do is change it to a unit rate, just like we're doing for both of these. So Kennedy, what did you get for a unit rate for this one?
I got 1 pound of food. Wait. So
You're going to put in your calculator 5 and divide it by 45.
9.
That's 1/9. Would you please divide it? 5 divided by 45. Hang on. 0.1 repeating. So she's getting, this cat's getting 0.1 repeating pounds, a little more than this cat, right? Per day, in each day. Not a lot more, but 0.011111 more. So whose cat's getting more? Crystal's. Why? Because 0.1 is bigger, 0.1 repeating, right? 0.1 repeating is greater than 0.1. Okay? So, question.
Okay, so I did it where I said how many days spent on a 1 pound. I don't understand that.
Okay, so that's what he did also. How many days per pound?
That makes more sense.
But if you're feeding your cat, don't you want to know how much to put in their dish
'Cause you can just
each day?
divide the pound in half.
But like you would want to know, do I put in 1/4 of a cup? Do I put in 1/3 of a cup? However I'm doing that, right? So I know it might not make sense, but I'm telling you this is how you want to do it.
But like,
So just wait, okay? So we're going to do a couple more. So let's look at number 4 before we go on. Elizabeth, in number 4, they give us a rate, and they are asking us first to find that average rate or our unit rate. How would you find it? Because on the quiz, I need to see this in this story part of the problem. What am I going to do? I'm going to take 240, and I got miles per 4 hours. My unit rate, Greta, is 60. And I can write it this way. Now, yesterday we talked about equations. And we said when we write an equation, we are always putting the dependent variable equals our unit rate, UR, that's going to be unit rate, times the independent. So what is my equation? And again, you could use y and x, or you can use miles and hours. So yesterday, I know I started to mark wrong on that little quiz paper that you did. if you had the equation y equaled 60x, that would be awesome. If you had y equaled 60h, I started to take off a point, and then I was like, oh, I see why they used h for hours, okay? So I gave you credit for that. But I just want you to be aware that when we're writing this equation, I either want it to be both y and x, or if you use hours, then you would want to use miles here, right? Does that make sense, the variables? Because we're talking about miles and hours, or we're talking about y and x, okay? Number 5. Brooke, what'd you do for number 5? It asks us to find gallons per mile. What did your answer look like? 0.1. Because if you look at that, this tells us 10 miles per gallon of gas. And if you're putting gallons, you need to put the word gallons here, and you need to put the word miles here. And they already told us it was 10 miles, and this is 1 gallon when you look at that. So her answer of 0.1 gallon per mile, I agree. Could you have left it as this fraction and put 1/10 of a gallon per mile? Same answer, okay? All right. Number 6. Kennedy, any idea how you set up number 6 or what you did? Give us an idea how you did it.
Okay, so I did
Point
point
kind of
one.
using 5, right? Okay. 0.1.
Yeah, I did 0.1, and since you need 220 miles, I did 0.1 times 220, and I got 22 gallons.
I like that. 0.1 times 220, right? So if we are looking at that, we're going to take 0.1 times our 220. Did anyone do it differently?
Me.
Okay. We're going to get 22 here. How'd you do it, Sam?
I did 220 divided by 10.
So because we got 220 miles, and we know that we went 10 miles, okay? And so we could have divided it that way and got 22. Did anyone use a proportion? Like using this proportion over here, putting 1 gallon to 10 miles equals, we don't know the gallons, right? X, this was our gallons, to 220 miles. And if you did this and you flip these two around, it would still be that same ratio, yep?
I have a question on number 5.
Okay, hang on. So when we look at this one, both ways here, I can take this times 10, so I get 10x equals 220, and I'm still going to divide. Make sure you label your answer. If you set up this proportion, you could have said, oh, I have to take 10 times 22, right? That gives me 220, and 1 times 22 would give me 22 gallons. So I've showed you at least 3 ways of solving that. When you get to the quiz, you just got to make sure I see how you solve the problem, okay? If you don't show me how you got it and you just put 22 gallons and it's a 4-point question, I'm giving you 1 of the 4 points. You got the answer, you didn't show me your process. Question on this one. This was our given information, 10 miles per 1 gallon. It says what is the rate in gallons. The per is trying to tell us the division line. So we have used the same information, 1 gallon, we put that in our numerator, and we put the 10 in our denominator. And 1 divided by 10 is 0.1. Or you could have had 1/10 of a gallon per mile. Okay, you could write it out this way also. All right, so 9 and 10. Some people totally forgot that there was a back. I had some other people tell me, I didn't even see that there was a back to this. So we aren't going to hand this in today just because if you didn't know there was a back, I do want you to do the back before we bring this in. But before we can do question 9, and it says after purchasing, how much is the card now worth, we might want to figure out how much we're paying per minute. So number 8, Greta, what'd you get for an answer in number 8? Got 0.06, and then did you give an equation also? And so if you were doing this, tell me what were the numbers you got divided to get .06 per minute. So we had $5 originally, and we had 80 minutes. So she divided, got 6 cents per minute, I agree. It now says, okay, you've just called for 15 minutes. So how much money have you spent?
$9.
Wait. 15 times 6 cents. How much have you spent? Not 60 cents. 6 cents.
0.9.
90 cents, right? We spent 90 cents. So how much is left on our card? We have to take the $5 originally on our card, right, and subtract 90 cents. How much is left on our card?
$4.
$4.10.
In the back of the book it says 4.06.
It's wrong.
So then I thought I was doing it wrong.
No. Okay, another one that I need to mark down. Kennedy on the board over there, right, number 9E5.
Just
Okay.
anywhere?
Just anywhere. That's for me to remember to email our people who are going to write this. All right, so 10:11. It says her home calling card is, if we were looking at that one, is 8 cents a minute. Which calling card is a better buy? You guys can do that one, right? Which one is a better buy? I'm going to ask you a question like this on the quiz Monday. I'm going to ask you to compare two things, okay? So this one was 6 cents, this one is 8 cents. Which one's a better buy? 6 cents, right? It's cheaper. Why? 6 cents is less than 8 cents when I'm spending money on talking per minute. That's less, okay? And then this one is just asking you how many cards. You cannot buy a fraction of a phone card. It's kind of like buying gift cards. Usually they say, you know, if you're going to put this much money, you got to put this much money on the card. So you guys need to finish and check the answers if you have questions. We're not handing this in today. If you have not turned in E1, 2, or 3, I do want those. And this is what I want you to look at right now. Was there anyone absent yesterday? So this video is attached, and we did this, so you need to watch the video and fill that in, okay? For Monday's big quiz, I am going to give you a rate in a story problem, like we were just talking about. I'm going to give you the rate. What you will have to do is you have to find the unit rate. So it's going to look kind of like this, only thing on this one where we gave you 200 miles in 5 hours, right? That's what this was. So take this half sheet of paper out. The first thing that I had you do was find the unit rate. On the quiz, it's going to be the same thing. Only thing this is going to be in a story problem instead of a point on a graph. After you found that unit rate by dividing both things by 5, you found per 1, okay? You will then have to make a table just like this. I will just say, make a table. You will want to put the X and the Y, and you'll put the 0 through the numbers, okay? It will then say, make a graph. So then you will plot the points on the graph and draw the line. It will then say, write an equation. So once you have found your unit rate, we know it's Y times the unit rate times X, where this is our number. This is our unit rate, right? Okay? So if you got that wrong, kind of take a look at that. The other thing I'm going to do is I'm going to give you 2 tables. And I'm going to say compare them like we did in E3. I'm going to say, okay, who's making more money per hour? Based on maybe the equation and based on this story situation or on a table. You are then going to be asked to graph both of them. You're going to be asked to write an equation for both of them. And then you're going to say, well, why is this person making more? You have to explain sentences. Remembering from English that when you're asked a question and you just put down who makes more money and you put John and you don't tell me why, you don't say, oh, because John's making $15 an hour and Sue was making $8.50. You don't write that out. You just say John, 15. That's not an answer. It's not a complete sentence. It's not, okay, so just to make sure. I will be here tonight after school for a little while, and I will be here Monday morning at 8. Or during advisory. We have everyone advisory on our team, so if you need help or you have questions on this, come in. Turn to your notes. Proportional relationship. I need you to tell me what you know about proportional relationships. Kennedy, one thing.
It has to start at 0.
Start at 0, 0. I like that. That can be in our table too, right? Our X, Y table at 0 and 0. So both on a graph and on the table. Starts at 0, 0. What else makes it proportional? Can you have peanuts? Snickers?
Yeah.
Yeah? All right, Sammy, what else?
Like the straight line or whatever.
Graph, it's a straight line, right? Straight line. Okay? What does that look like in a table or any place else? What does that proportional relationship look like? In a table or in a story situation, how do they tell us it? The what? Numbers? How with the numbers? Like what's happening in our table? when
Like
it goes up?
$1 per minute or something?
Okay, so it's like telling us that this goes up by ones, 1, 2, 3, that this is a constant, right? We're adding the same number each time, right? So if I'm looking at that, that might be what's called our constant rate of change, right? So it's a straight line. There's a constant adding of the same number, right? Doesn't matter what that number is. If it was $15 an hour and each hour we add 15, adding the same number each time, and we're starting at 0, 0, okay? Anything else you can think of for proportional relationships? It is, when we look at these, it's usually talking about that unit rate. Now, here's my other hint. You're getting ready for a quiz that's going to be on E1 to E5. Go back and read through all of your notes. Maybe watch the video, go back and look at it, because if you only do it the first day we do it in class and then you think you're going to do great on that quiz, some of you have great memory, but a lot of you don't. You forget things. I need you to focus on this, not doing that, okay? Or on the notes, right? Okay. So, as we are continuing, if you don't have a calculator, you're going to need one. Today what we're going to look at is we are going to be looking at investigating distances using both miles and kilometers. And we are looking at these different cities from Fargo. So this is the distance Minneapolis is in miles and then kilometers. Chicago, Sioux Falls, Bismarck, Billings, Winnipeg, Omaha, and Denver. Notice Omaha and Denver have nothing here. We're going to try and figure those out, and we're going to do it using our unit rates, and we're going to be using our constant rate of change. So turn to the next page, please, and you are asked to graph. What are you graphing? On the bottom, you're graphing, so the first 6 points from the data table. What data table? Here, this is your ordered pair. This is X put above distance, X put above distance in kilometers, that's your Y, okay? Plot the points. I don't know exactly where 235 is. I don't either. You're approximating, right? So 235, 379. 235, maybe here, someone else might put it over a little further. 379. You're going to put a point there. Now you're going to go to the next one. The next point was 643. So it's this table that's down below. Only do through Winnipeg. We're not doing Omaha because we don't know the other number with Omaha. We're not doing Denver because we don't know the other number with Denver, okay? So plot yours. Check with your shoulder partner and kind of see if you agree with the points you're plotting. Just right on the bottom. It's right on the bottom. Use this one right on the bottom. Right on the bottom page are the points, okay? You don't have to flip back and forth. This is right below, okay, on your notes as you're looking at it. Yep. Question. So this is your X. So you're going to go to like 200, right? And then you're going up and you're putting points. So like these three are kind of all clumped together, right? Okay, that's okay that they're kind of together. And then you got these other two way up here that are further away from Fargo. Okay? Does that make sense as you're looking at your graphs? So it says, what pattern or shape do you see with the points on the graph? What could I do with these points? Using the edge of your workbook or the edge of another piece of paper, could I make a straight line?
No.
Could I take and connect? So it says, what pattern or shape could you possibly see with your graph? And it says, it's kind of dependent on how you plotted your points, but possibly a straight line. Now, there might be 1 or 2 points that are off just a little, or maybe your estimation was off when you plotted it. So it says connect the points to illustrate this pattern. So take the edge of your workbook, take the edge of that half sheet of paper, and connect this, making a line. And then it says, let's approximate what 424 is, right? So remember 424, and I want you to write this here. Do not write it down below, okay? We're gonna say we think approximately 424. I want you to go up from where you think 424 is and tell me what number you think it is going across, okay? So as you're looking at 424, what are we thinking might be the numbers as we are looking? So it could be
500.
could be 500. I think it should be a little more than that.
Where? Oh, I got
A little more.
it. Oh, yeah. That's what I meant, 650.
Maybe 650. Yes? Yes. Okay. So maybe 650. Anyone see it maybe more than that? Natalie.
I feel like 7.
Maybe 720. I would take both those answers, right, from here, because we're just looking at our graph and you're kind of going over. Now 720 might be getting a little further over, like because this is 100 in between here, right? So 424 is going to be pretty close. So we'll say a good estimate would be between those two. Now let's go across from 1374. 1374, it's going to be less than halfway, right? Where do we think that's going to end up? Go down. So 1374 is where we're looking at that. This was 1374 here, and we're approximating this. Approximately, what do you think, Daisy? Maybe 690? Anyone have another number that they think maybe? Kate, what do you think? 680, I agree. Anyone else?
800?
Maybe 800? You think it's that much?
How can you have
Yeah, I'm confused.
How can you have 1,374 if it doesn't even go that?
That's in kilometers. That's the Y part.
No, yeah, but the next number is 1,100.
Oh. So 1374, way up here, right? So we don't even can't see it on our graph as we are looking at it. Who did I miss? Kate. And who else?
Started.
Oh my God.
I answered 720.
Like
Did I get
800.
Who else did I miss?
I
All right,
don't know.
so this 1374, way up here, right? So when we're looking at these answers, Jordan said maybe 800. Jordan, did I give you candy already?
Yeah.
All right, so can't get more. Can't get more than one. All right, so let's now go here, and on the bottom, this is where you need your calculator. We're going to do some division. It tells us we're going to put kilometers on the top, and we're going to divide it each time by our miles. You don't have to write this down. You just need to put 379 in your calculator first, right? You're not putting 235. 379, you're putting the kilometers first. Y's divided by X's. Get used to that. Y divided by X. Algebra students are still struggling with that, finding their rates of change in slope right now, okay? You will be doing this all of next year for a good portion of algebra. Y's divided by X's. So what do we get for the first one? 1.6. We're going to estimate it, right? Because it says up here to round to the nearest 10. So now take the next one, and you don't have to write this down, but remember, you're taking the 1,035, you're taking the kilometers, and you're dividing it by miles. 643. And just check with your shoulder partner as you're doing it with your calculator. Do you need just a regular pencil so we can write? Okay, cool. Fill them in. Use your calculator. Do it right now. You're going to start noticing a pattern, and when we start seeing a pattern in mathematics, we love it. And after we check a couple in that pattern, we go, yes, I don't know that I have to keep doing it. Maya, how you doing putting them in? It is. It is. Keep going. Keep writing it in, right? And once we start noticing, like we did the second one, and some of you go, oh, I got 1.6. And you did the next one, and you estimated, and you got about 1.6. So now just try 357 and divide it by 222, right? We start noticing patterns, and we don't have to maybe do division on our calculator all the way down, right? But we're going to stop. But do you think this pattern should continue for these next two, that it should be 1.6 also?
Yeah.
Yeah. We're going to put 1.6 there, okay? Everyone have that table filled in? How come you didn't? Oh, you're going to have to go back and grab them, okay? At least put the points. Okay? So now, turn to the top of the next page. This is where we're using what we have for our equations. And it says, okay, the number of kilometers in every mile is that constant. That constant is our unit rate, right? That constant rate, which in our case was 1.6. 1.6 what? Kilometers per 1 mile. That was my unit rate, okay? So, I know that 1 mile is about 1.6 kilometers. So it says, okay, now we're going to, how many changes in x to y kilometers? Using variables, write an equation. Remember, our equation is the dependent variable, please write this down, is equal to our unit rate. So when you take your quiz Monday, you're just going to get this, times the independent variable. Our independent was x. Our unit rate was 1.6. Y equals. I will have some people like to put this as miles equals 1.6 times the kilometers. Does that make sense? When you looked at your graph, our miles was here, right? So did I have it right? Miles equals, should be kilometers equals 1.6 times the miles. Miles is our independent, right? That's on our x-axis, horizontal. Vertical is the dependent, okay? So it says use the equation above, and let's figure out for Omaha and Denver, okay, what those distances are. So we're going to use this equation, y equals 1.6x. What did you know in Omaha? You knew miles, right? Is miles x or y? X. So, if we are looking when x equals 424, we're going to use this equation and solve it. Y equals 1.6 times 424. How close are we on our estimate? Y equals, what'd you get when you put it in? No. 678. We were pretty close then, right? Our first estimate, 678. Our first estimate, when we did it the first time, we said 650 to 720. 650 was actually really close, right? Okay. So now let's check the other one. So now when we're looking at the other city, the 1374, is the 1374, is that y or x?
X.
It's the y. So this time what we know is that y equals 1374. So in this equation, we're going to put 1374 equals 1.6x. What am I doing this time to solve? Raise your hand. What am I doing this time? Devin. Dividing. Personnel, what am I dividing by? By 1.6 on both sides of my equal sign, right? Okay? So, please do that. Take 1374 and divide it by 1.6. And x equals, now what'd you get? 858. So when Jordan said 800, right? That was a pretty good estimate, that it's way over here, over 800, okay? All right, so on your test, you're going to be asked to do some work, or on the quiz Monday, you're going to be asked to do some work like this. I am going to tell you one of them. One time I tell you like the X, the other time I tell you the Y, and you got to figure out the other one. You know how to solve equations. That's why we did equations before this meeting, right? All right. So it now says, okay, we get this 1.6x. These are my red dots. Why does the line go through the origin? Because what do we know? At 0 miles, what's the case? Remember, this is our miles. When you drive 0 miles, it's 0 kilometers, right? 0 kilometers. Write that down. The next thing we know, why is there an arrow at the top and not at the bottom?
Because it doesn't go below 0.
Because why? Can we drive negative miles and negative kilometers?
No.
No. Can't drive negative kilometers or negative miles, right? Doesn't make sense. And the reason it continues on is if we use what if we use 10,000 miles, we drive 10,000 miles, we should be able to find out how many kilometers, right? So it continues on forever, okay? So, when you are looking, this next part, this is what you're going to be asked if we are looking at our homework today. And on your quiz, the quiz looks kind of like this one. And it says this, okay, we're selling these ice blocks, which is very appropriate for this time of year. Like in Grand Forks, usually around Christmas, they have like the shaved, they have the ice displays, and restaurants sometimes do it. Minneapolis, they have their winter carnival coming up in January. They're charging us $143.75 for 5 blocks of ice and $87.75 for this company for 3 blocks. It says, which one is a better deal? What do you need? What am I looking for? To compare the two, because I want to do this. I need unit rate. So please write unit rate right here. And on the quiz, you can't just tell me the unit rate without showing me how you got it. So Bergen, if I'm looking at Iggy's company, how are you going to find it? What would I write down? What's going to be in my numerator to find my unit rate? Yep, what amount? Tell me of these two numbers, what are you going to put first?
So, 143.
You got it. 143.75, right? Divided by 5 blocks. Because I'm trying to find out how much 1 block costs. Use your calculator. Please do it then for the next one. Did I miss you before when you answered? No, I didn't. You have an answer? Do you want to answer? Tell me to set up Bob's. Okay.
You do 87.75.
80 divided by 3. Put your dollar signs. Put the word blocks. Oh, do I have to write this? Yes. Our final answer is per 1 block, right? 1 block. And we're going to have a dollar amount. Use your calculator. Tell me, what am I looking at? Greta? Did I give you one already? Okay, go. First one was? Okay, second one? What do we have? Haley, you got it? Second one? $29 point, how much? 25. Which one's a better buy?
Obviously,
Iggy.
There's the IGGY. Put that name in blue.
So it says write equation for both. Please do that right now and check with your shoulder partner. I need an equation for Iggy. Ice shop. And I need one for Bob's. Write it, share it with your shoulder partner. Both of them should be in the same form. Y equals, that's our dependent, remember? Equals something always times our independent variable. First equation, Natalie, should be, actually I need you guys to talk. Talk with your shoulder. Yes, y equals 28.75. Whatever that unit rate is, when you take the quiz Monday, the unit rate times x. My other equation, Sam.
Y equals 29.25 x.
Yes, okay. Your homework is in E5. There is a front and back to it. You are looking at unit rates. This one says, okay, write the unit rate and cost per 6-pack. So you're going to use the ad, use the information. Work on this, please. Get started. You got a couple minutes. You probably can get 1 and 2 done. Work with your shoulder partner. Help each other out. When you come in on Monday, I will answer a few questions on this before we take the quiz, but I'm not going to take a lot of time.